There are more stars in the universe than grains of sand here on Earth, and nearly every star has its own planet. That's why, as of right now, scientists have discovered thousands of so-called habitable planets. Among these, Proxima Centauri b and Kepler-22b stand out as the most enticing options, a home away from home. However, despite the widespread belief that each of these planets are our future homes, there's a significant hurdle that we cannot overcome. Each planet presents a major challenge, so big that it would be impossible to ever set up a habitable colony on any of these planets. But first, what does habitability look like? There are three characteristics that are vital for humans to live. First is liquid water. The function of liquid water may be the most understated aspect of life. On Earth, every known life form requires water to survive, but water's unique properties, such as its ability to dissolve almost any substance and its role in regulating temperatures, make it essential for life. For a planet to host liquid water, it must orbit within the star's habitable zone, the range of distance where temperatures are just right for water to remain liquid on the surface, without freezing solid or boiling away. The next characteristic that is essential for habitability is an abundance of heavy elements. For life as we know it to exist, a planet must have access to the essential chemical building blocks of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements are the building blocks for organisms and the fundamentals of life. Everything from the structure of DNA to the functioning of cells and the unique energy transformation that sustain life processes. Take carbon, for example. Carbon's unique chemistry allows us to bond with a variety of other elements, including itself. It forms long chains that serve as the backbone of organic molecules. Without carbon, food production and agriculture would be impossible, as plants rely on carbon for photosynthesis. Finally is a magnetic field. Often overlooked, a magnetic field adds an indispensable layer of protection by deflecting charged particles from the sun, including solar wind. These powerful solar winds can slowly strip away a planet's atmosphere if left unchecked, turning the planet into a desolate, empty landscape. This magnetic shield helps preserve the atmosphere, and by extension, the conditions necessary for liquid water to exist. Together, a protective atmosphere and a magnetic field create a stable environment that can support life. Okay, so back to Proxima Centauri b. Located 4.2 light years away, it lies in the habitable zone of Proxima Centauri, the closest star to our Sun. The planet's orbit suggests that it could have the right conditions for liquid water to exist on its surface. Theoretical models suggest it may have an Earth-like atmosphere, raising the potential for habitability. However, there's a significant challenge. Proxima Centauri, the sun that lights up Proxima Centauri b, is a red dwarf, which emits violet solar flares. These flares are powerful enough to strip away the planet's atmosphere over time, exposing the surface and potential life forms to a deadly amount of radiation. This would likely kill any chance of habitability by humans. Turning our gaze to Kepler-22b, do we see a different story? Located 600 light years away, this planet looks like it too could have the right conditions for life. Kepler-22b's size and location hint at the possibility of a warm, possible hospitable climate, ideal for liquid water to exist. But there's a problem. Kepler-22b weighs an astounding 1.929 times 10 to the 30 kilograms. That is 36 Earth masses and a radius of 2.38 Earths. Because of its immense mass, it very likely does not have a solid surface. The planet's size and mass hit at a composition that could range from a water world with deep oceans at best to a mini-Neptune with thick gas envelopes, neither of which are suitable for any type of terrestrial life form. If that's not bad enough, without a magnetic field similar to Earth's, the planet will be exposed to harmful cosmic and solar radiation, eliminating the potential for life. So that's it. Is all the potential for habitable life on exoplanets gone? No. Among the exoplanets, if we can get to it, there's one that stands out. One that we think might be able to support life without any of the pitfalls of these others. This is TRAPPIST-1e, one of the 7 planets orbiting the ultra-dwarf star TRAPPIST-1. Located approximately 40 light years away, since its discovery, researchers have spent countless hours scouring the planet searching for life. TRAPPIST-1e is about the same size as Earth, and not only resides well within its star's habitable zone, but it also exhibits conditions that could potentially meet all 3 success criteria: liquid water, an abundance of heavy elements, and a protective magnetic field. Observation of the TRAPPIST-1 system through spectroscopic analysis and planetary modeling indicate that TRAPPIST-1e, along with its sister planet, possess a significant concentration of heavy elements. While direct evidence for a magnetic field around TRAPPIST-1e is still forthcoming, its Earth-like density and size hint at the possibility of a molten core. Such a core could generate a magnetic field similar to Earth, giving us protection from stellar and cosmic radiation. This magnetic shield would be crucial in preserving the planet's atmosphere and surface water. Don't get me wrong though, the TRAPPIST-1 system is very different from Earth. Planets are orbiting a tiny red dwarf star, roughly the size of Jupiter, and the star is much cooler than ours. This means that all the planets would have to be close to the sun. But imagine living here. Imagine how life would be exciting, whether it's going on a tropical paradise on TRAPPIST-1f or a beach resort on TRAPPIST-1d. It's our world to uncover.